Welcome to another episode of the Tech Vault with me, Mitchell Sellers. Today is a fun one. I love taking time to talk about or share stories about the things that we learn from, and this happens to be a really real story of something that happened to me recently here. And the idea behind this talk is hidden tech debt. Those things that we sweep under the rug, the things we know about, the skeletons in the closet, it's still there. It's still tech debt. And I was greeted with something that was very surprising, a tech debt problem, something that had been working in production for an incredibly long time, incredibly reliable, hadn't had any issues, been used in multiple different places, no issues whatsoever. And then all of a sudden, boom, one day, everything comes crashing down. One of the hardest parts with some of that is understanding, what do we do? How do we start to diagnose it? Why is something going to come back and catch us later? And we always talk about that tech debt, that it's important, that something that we really do need to pay attention to and not necessarily look at. So with this one, I want to just kind of dive into a real production scenario, show a little bit about what happened, what some of the signs were a little bit, and kind of dive right in. From an overview perspective, we had a client. The web application that was in question, it was a content management system based front end that communicated to a .NET Core backend. Those communications were done via web API connections. The application in its current form has been live in production for more than 5 years. Some of the frameworks and functionality have been in production and in use for more than 10 years. So a very long running project, incredibly successful, stable, never really had any outages, never had any issues. But one of those things that over time, right, the client gets more active, we get more volume. All of a sudden, we start getting notices that the website's unresponsive. And the website was fine as long trying to make, it would respond to regular requests for content. It would respond to individual things without any problem. But every single time that it was trying to make a web API call, we would get an error message that said, failed to make TCP connection, failed to make TCP connection. Okay, so we start doing all of the diagnostics. Is it the firewall? No, nobody changed that. Is there any VNet rules? No, nothing changed. Are the APIs working? Yeah, they work. Are the APIs being hit but throwing an error? No. The request never even made it to the APIs. Well, that's weird, right? What could cause that to happen? Well, this happened to be a client that was hosted in Azure. So we start digging in, we look at the diagnostic tools. And one of the fun things that a lot of us maybe don't always think about on a regular basis is the concept of SNAT port port usage. And so the idea here is that each outbound connection process from within your application needs to utilize a port for your outbound communication. And what we can see here is in this scale at the very top, it's the total number of SNAP ports that are being used. We then have something happen, and then we have in the middle section here, we have our pending SNAT connections in terms of how many requests do we have that like we need a connection, and then how many do we have that are failed. And by golly, something happened at about 9:07 a.m. if we're being honest here, right? We were using a lot of ports, more than we probably should have for a website that's a little bit chatty. But all of a sudden at 9:07 a.m., the world just went dark. The number of pending and failed, just to give you an idea, they're pretty much exactly the same. If you took the two charts and superimposed them, they literally match each other. So what that shows us is all of a sudden something happened where we had so many failures. We had so many different things that the application just completely stopped working. Now, this was a sudden thing. We still don't fully know what triggered the exact end of it, other than we do know that at approximately 9:06 a.m., the site was hit with some bot traffic, specifically a couple of AI scraper tools that tried to aggressively go after a few of those APIs. One thing led to another, a couple of error messages happened, and then kind of the world started to unravel. So we start digging into this and we start looking at port exhaustion. And one of the number one things, right? Why would we have a port open? This goes back to the age-old diagnostic thing that we've been talking about for years, whether it's HTTP requests or whether it is individual requests from a SQL Server perspective, right? Unclosed or unmanaged connections, right? That's normally what the root cause of this is. But this code's been in production for over 10 years for the pieces that were responsible for the API communications, right? Should be fine. Now, keep in mind, this is a .NET framework project because it's used inside of the content management system. So there hasn't been a need to do those big evolutions, from .NET 6 to 7 to 8, et cetera, right? So this is code that is truly legacy code, but it's been working. It's been stable. It's been, leveraged, even load tested to a certain extent. So we started digging. We know where our problem is, right? If we don't have any ports available to do outbound communication, we're not going to be able to communicate to our web APIs. Absolutely makes sense why we have a failure going on. So then what we have is we start to go take a look at the code that we have out here. In our old code, we have some helper methods, happen to have a generic method here that is utilized to help us identify, make all of the decisions and look at, making those post requests a little bit more reasonably. Now, again, .NET Framework code, older code. At first glance, a couple of things look okay-ish, but maybe not exactly what we want. This protocol version of HTTP version 1.0, it seems a little silly, a little suspect, but maybe not the end of the world. Okay, we add our request headers if we have them. We have an accept string. We get our response object. Okay, so as we get through here, things are looking reasonably correct here, right? We've got a using statement around our HTTP response. We have a using statement around our response stream reader that we have. As we continue to go down through the code, we do this, everything, reasonably not horrible here, right? Now, when we catch our exception though, oh, that's not good. We don't actually process that well at all, do we? We don't have a using statement. We're not handling that exception or reading that response stream appropriately at all. Now, this code, again, it's been out here for a long time. I'm not going to punish 10-year-old me for what we were doing here, but definitely something that maybe we want to take a look at. So as we go back and look at this code, we take a quick bit. This is one of those cases where, we used, all the different kind of tools. We know the best practices, but one of the things we were able to do is, go to Copilot and say, hey, we believe that this code is having some problems where it's leaving connections open. We want to make sure that we're using a pooled set of connections and reusing things if we can, following the best practices as they relate to .NET Framework 4.8. So we go back, we let AI churn on that for a couple of seconds, and then we get an updated version of our code. Now, this is where things get a little bit interesting. Now, instead of setting our HTTP protocol to version 1.0, we remove that, go back to the default, which is good. But we also are now setting request keep alive so that we keep that request out there so that we can reuse that connection if we have possible. Everything with our header and stuff stays the same. But now if we look at our happy path, the response stream, and the stream reader of the response stream are now properly wrapped with a using statement so that each individual piece of this process is properly disposed of. A much better way to make our handle and be able to process the objects. If we go down into our exception criteria, we have the same behavior going on here where we're now properly capturing everything. This is a simple fix, a very simple, easy best practices fix. The result, the change didn't take very long at all. Now, this is something that if you are doing a new code review, if this was brand new code, you most likely would have caught that. If you had your AI code reviewers out there, this is something that more than likely would have been caught by that code review process or anything else. However, we didn't change this code. The last modified date on that block of code was roughly 8 years ago. So the reality, though, is, well, what happened? So we didn't know about it right away. The client let us know there was some problems here, back and forth. The site was sort of usable, sort of not usable. At the end of the time period here on the far right, where everything just dropped down to practically nothing, not only did the site come back online, instead of us using between 600 and 800 SNAT ports at a given time, those simple text changes or simple method changes that I showed just a second ago resulted in our project going from, using 600 to, 1100 SNAP ports to using only 14 to serve the same amount of traffic. So by turning the keep alive on, by properly handling our resources, which are all of the things that we want to do on a regular basis, we were able to restore functionality for the client. We actually improved the average page response time by approximately 40%, which wasn't bad beforehand when everything was happy, but it's even better now. And this is one of those cases where when we talk with clients or when I talk with folks about, well, our project is okay. We don't necessarily need to touch it. Sometimes we might make a decision that was okay back in the day or easier to do back in the day, or maybe that wasn't the best practice that was fully documented. It's very easy for these little things, right? These pesky little things, as I like to think of them, that are out there, but they don't bother you until that day that they do. And this is one of the reasons why it's really important to continue to go out, manage and review your code, take a look at the things that you're doing, and make sure you have an understanding of why you might have an issue or areas that you're looking to, do things that might release resources or leak a resource that is going to cause you some problems in the future. So one of the things that we took from this, and I've taken from this with our team, and we're working towards making a larger community understanding with, is we've been working on AI review tools that meet our standards, that meet the expectations that we're looking for. And one of the things that we've done is we've started to create some tooling to recognize tech debt in existing projects. A tool, if you will, that allows you to go back and look at a legacy code base and say, is this code meeting the best practices standards for resource management? Is it meeting the best practices standards for how you work with Entity Framework? Is it meeting the best practices standard for the use of HTTP client? And those kinds of things, and creating some actionable lists. Because at the end of the day, our tech debt is still tech debt. It might be hidden. It might not be an issue that causes you pain today, but it is something that can absolutely come back and get you in the future. So being aware that you may have those things, as we start to look at what can we do, how can we take AI and use it to help us be better people? Well, we can help it. We can use it to help us identify the issue, feed it our diagnostic data, right? Feed it the information that, hey, I ran out of all of the SNAP ports that were available to me. Why might this code base be broken? Absolutely helps you diagnose it a little bit better if you don't have that level of network understanding of what might be happening. But then we can also use that to take our learnings from those things that we do every day and say, hey, I know this is a best practice. Let's use AI to help us make this better. Let's be able to introduce this into our processes, into our code review processes and otherwise. And so we'll continue to talk about this. I'd love to hear, what things have you ran into that have been those hidden tech debt, those things that have sat out there for a long time? How long have they sat out there, and what was the trigger point? How did you end up learning about it? Hopefully it wasn't an outage. Hopefully it wasn't something that was really big, but I'd love to hear what you've ran into and the things that you like to do, or how you're working to combat and move forward with that hidden tech debt and try to bring things out from underneath, behind the walls and out of underneath the floor, and make sure that it becomes a number one priority to get resolved to make sure we continue to make things stable. Hope you enjoy. Like and follow for more. Working to create more content. Share in the comments. I'd love to hear what you'd like to hear, what your experience has been, or what we should talk about next here on the Tech Vault. Thank you.